All right, so we are going to take a look here at the beginnings of chapter 7 today. Yesterday in class, we had the Desmos activity that kind of introduced the ideas of both the multiplication properties and the division properties. Today we're going to look a little bit more in detail into the multiplication properties. So in fact, we're going to find out there are actually 3 of them today that we're going to take a look at. At the end of today, there's going to be a 15 question form that's going to go along with this. So as we kind of look through some of these things today, we're going to get into, you can see here, what's called the product rule. That's something that we actually were doing yesterday in the Desmos activity. And then off of that, we're going to get into the power rule. And then we're going to get into what's called the power of a product. Okay. Before we get into that and lining up with your form tonight, we're going to talk about what is a monomial. I'm just going to give you a definition kind of right off the bat of what a monomial is. But today, can we multiply monomials? So in a second, we'll talk about what that means, all right, using these properties. And then can we simplify some expressions? You'll see those at the end of class today. There are actually 4 of those that we're going to take a look at. But for the beginnings here, if we talk about a monomial, hopefully when you see the word or hear the word monomial, you to take that prefix of mono and you understand hopefully that that means one. So the question would be one what? Well, a monomial simply could be one, what we call a term, and that term could be, could be one number. So for example, 25, that is a monomial, or -7, that is a monomial, all right? It could also be one variable, all right, or a product of variables. So x is a monomial, all right? X, Y, that's also a monomial. It's still one term, okay? Could be, A, C. That could also be a monomial. And then the last one would be one, what we would call, product, I guess, of the two together. So for example, 5y, that's a monomial, or -2xy to the third, that's a monomial. Okay, what you don't see here in a monomial, okay, so in a monomial there is no addition or subtraction. Okay, we have a negative sign here in this -2xy to the third, but we do not have an addition or subtraction sign, and we don't have division. You notice that either. All right, now we could have a fraction, 2/3, that would be fine, but we would not have a fraction where maybe variables are in both the top and the bottom, so to speak. So a monomial is one of these things. It's a number, it's a variable, or it's a product of those two things together. And then obviously a constant is just something that does not change. So in this case, 25 or -7, those would be constants as well. All right. Now, this sheet here, or this slide, is something that we're going to use as we work through both the multiplication and the division properties. Today, we are going to be looking at these 3 right here. So the first one, the same base does not appear more than once in a product or a quotient. Okay, that's the product rule, or what could also be known as the quotient rule, because it does have division as well. The second one, no powers are raised to powers. That's what's known as the power rule. Okay, it's the second one we're going to get to today. And then the third one we're going to look at today, no products are raised, or excuse me, no powers are raised to, I can't read, no products are raised to powers. Sorry. That is what's called the product of a power rule. Okay. The part I like about this, twofold. Number one, it gives us some specifics as far as when things are simplified. Okay. So, unfortunately, an exponential function is completely simplified if the following things are true. Okay. No negative exponents. We'll get more into that later in this chapter. For right now, we're going to let it go. So like yesterday in your work, a lot of you guys had negative exponents. Totally fine. We'll get more into that as we go. Okay, these 3 that are circled today, we're going to get into, and then obviously the 5th one, no quotients. That's something we're going to talk about in the days to come. And this last one, numerical coefficients and a quotient don't have any common factor other than 1. That's fancy words to just simply say reduce. Reduce a fraction if you have it. Okay. The other part I like about this is every one of these questions shows you an example of what is good and what is not. So for example, this very top one says no negative exponents. The first example in both sides shows you a no and then what it should look like as a yes. Okay, so over here on the left-hand side, a to the negative second power. Okay, that obviously can't be if you can't have a negative exponent. So somehow it's going to end up looking like what we see over here on the left, which is just simply b divided by a. All right, more specifically for us today, here's the first thing we're going to touch on. We don't see a base appear more than once. So here's an example of a base appearing more than once, but that answer is going to turn into x to the third. That's something we did yesterday, right? If we look over here on the right-hand side, there's a power of 1 and a power of 2. And if I put those two things together, I do get a power of 3. So we can see how a non-example and then a correct example also work to all of these things. All right. The next three examples, 1, 2, and 3, we're going to look at, though, are the three that we're focusing on today. So here's number 1. All right. This is something we did yesterday. Okay, so if you don't remember, you weren't here yesterday, okay, how do I handle something like this? Well, the first thought is I think about it in expanded form. Okay, so x to the second really could be written as x times x. X to the fifth could be thought of as this repeated value of x 5 times. All right, but if I put all of those x's together, I end up with x to the seventh. Okay, so we said yesterday that if we were going to go from there to here, we simply would look at taking that 2 and that 5 and adding those two together. That is what is known as the product rule. Okay, the product rule says if you have the same base, you can take the powers and you can add them together. All right. So kind of sticking along those lines, if we look at these three problems here, okay, I would ask you right now, pause your video for a second, and we're going to try these three, and then we'll come back together and see what we get for an answer. All right, so hopefully you have answers and you're ready to check them right now. As I look at this, I see this going on. There's a common base. There's a common base. It doesn't matter if they're variables like they are in example C, or if they're numbers like they are in example B. If they have a common base, I can put them together. So same base, take the powers, add them together. A 4 and a negative 2 would give me a 2. Here, a base of 3 I will keep. The powers are 4 and 2. I add them together. That's a 6. I cannot add these two together. The bases are different. I could leave my answer this way. Okay. I have no idea what 3 to the 6 power is. Honestly, it's not really what we're after right now. So leaving your answer like that would be totally fine. In the second one, the Q's are the same. So hopefully you put those two together for a result of Q to the 9th power. I can't do anything with the R to the 2nd, so I leave it. All right. Down below, all three of these are the same. Okay, even though it's not written, there's a power there of 1. If we put all this together, a 3, a negative 4, and a positive 1 actually has a result of 0. Okay, so for now, we'll leave this as n to the 0. Later, we'll talk more about what happens when you raise something to the 0 power. Okay, but this is what's known as the product rule. This is what we were looking at yesterday. Okay, this is the product of powers put together. That's number 1. Here's number 2. What if I have a base and a power raised to a power? Okay. Now remember, this power on the outside is telling me how many of what's on the inside that I have. And conversely, the same with the inside. That power of 3 on the inside is telling me how many of those x's that I have. So for a second, if I thought about rewriting this, I really have x to the third 4 times. I said 4 and then started to write 4. Right? X to the third, I have it 4 times. Well, we just learned a second ago, according to the product rule, that if you have the exact same base, you can keep that base. and you can add those powers together. So 3 plus 3 plus 3 plus 3 is a grand total of 12. Okay, well, now the question is, how do I get from there to here without having to write all that out? Well, that's what's known as the power rule. Okay, and the power rule says that if you have the same, or excuse me, if you have a base raised to a power, let's see if we can get this on the same slide. We can all see it at the same time. There we go. That if we have a base and a power raised to a power, then I can take those two numbers, in this case a 3 and a 4, and I can just simply multiply them together to get to a 12. I don't need to write out all these x to the thirds to get to that result. Okay, I can do that if I want to, or I can take those two numbers, multiply them together, and get that result. Okay, so with that in mind, I have just a couple problems here. Okay, looking at this first one, right? A base and a power raised to a power. So I'm going to multiply those two together. This result here would be 4 to the 0 power. All right. Over here on the right-hand side, again, I have a base and a power raised to a power. So this one here would be x to the negative 15th power multiplied by x to the 4th power. And now, because I have the same base, I can take those two bases. I'm not multiplying these now. Remember, I'm going to add those, and I end up with an answer of x to the negative 11th. Okay, so try this one. Take a second, pause your video, come back, let's check it and see if we have the right answer. Okay, so power raised to power. That would make this one a to the 12th. Again, power raised to another power, but this has got two negatives, so that would make a positive, a to the 6th. And now because I have the same base, I can take that base and add those together, and I get a grand total of a to the 18th. Okay, so this is what's known as the power rule. If you have a base and a power, you raise it to a power, well, you just multiply those together. All right, last one for today. Well, what if you have a product that's being raised to a power? Well, the question there says, well, rewrite it. Okay, well, how? That 3 really says that I'm going to have 3 of whatever's inside of there. So that means 3 of these 2 y's. Well, now I could use the product rule from the very beginning and rewrite that. So 2 times 2 times 2, that's really 2 to the 3rd. And then y times y times y, well, that's really y to the 3rd. So my final answer would be 8y to the 3rd. Okay. Or is there some way I could get from the beginning to the end? Okay, so take a look at those two and tell me, is there a way that we could get from the beginning to the end? And in fact, this power of a product is kind of like the distributive property. If you thought about this 3 right here, going to the 2 and then going to the y, notice you would end up with the 2y to the 3rd and then the y to the 3rd, and those together would give you the 8y to the 3rd. So we're kind of like distributing. If you could see my air quotes right now, we're not really distributing, but we're kind of distributing. Okay, we can think about it that way. And this is what's known as the power of a product. And essentially what we're doing is we're taking this power on the outside and we're giving it to everything on the inside. So we see that we get the 2 to the 3rd and we get the 4 to the 3rd. Or over here in an algebraic sense, you can see this n right here. It gets applied to the a, so there's a to the n power. And then it gets applied to the b, and that's where the b to the n power comes. So we kind of get this distributive look. Now, with that being said, let's look at these two problems here. Okay, so we'll try these two and then I'll have you pause your video and try the one at the bottom. Now these look very similar to each other, but they are just a little bit different, so let's be careful. That 3 has to get applied to the 2 and that 3 has to get applied to the y. We end up with something that looks like this. Okay. Now it's very important that I put these values in parentheses because in this case, I'm actually multiplying a -2 3 times. So if you thought about that, -2 times -2 times -2, that's -8 y to the third. But over here, it's a positive, or excuse me, it's a 4 that's being taken to both of these pieces. Now it's -2 times -2 times -2 times 1 more -2. That is actually a positive 16, and then a y to the fourth. Okay? So it's like the distributive property, but not quite. Okay, so last one down here. All right, so we're going to take this 2. It's got to go there, and it's got to go to the y. So if I write this, I get x to the 6th. That's being taken to the second power. And then it's y to the third, and that's being taken to the second power. Now this should look very similar to what we just had a second ago, right? When you have a base and a power raised to a power, what do we do with those two powers together right there? Hopefully you're telling yourself we multiply. So we get a 12 there. Again, a base and a power being raised to each other. That would be 3 times 2, or 6. I cannot put these two together because one is an x and one is a y. So that is my final answer. Okay, so I've actually used two properties here at the same time. The first one up here, I used the power of a product, more than one thing together, and then I used the power rule for the second one. Okay, all right, now let's kind of make this look a little bit bigger, kind of decide what rules we need to use when. So again, I would ask that you go ahead and pause your video before you try or watch the answers to these so that you can actually see, am I on the right track or not? All right, so in the first one, it looks like the only rule that's going to be used here would be our very first one, which is known as the product rule. And I know that because I don't have any powers outside the parentheses. So there'll be no power rule, there'll be no power of a product. In this case, I'm simply looking to put together my like terms. Okay, so if you're more of a visual person here, I might actually draw 3 sets of parentheses in this problem for the following reasons. I have coefficients that need to be put together, so the -5 and the 4. Notice here I have an x, and then I have an x to the second that also need to be put together. And then in the first part I had a y, and in the very end I had a y to the fourth. Okay, so I had 3 different things that needed to be put together here. Now I should be able to put my final answer together as -20 x to the third times y to the fifth. Okay, so using that product rule to help me combine these like terms. All right, now a little bit different than what I see in the second one. Okay, in the second one here, I do see a power outside the parentheses. So before I do the product rule like I did in the first one over here, I'm going to have to put these two together. Powers raised to powers tell me to multiply. So in my mind, I was already ready to multiply before I wrote the letter B. So here I get B to the 6th power. Now, I also have a 2, A to the 3rd, and B to the 2nd. So now I'm ready to put those together. But of these 4 things that I see, the 2, the A to the 3rd, the B to the 2nd, and the B to the 6th, the only ones that really could be joined together are these 2 right here. Same base, add the power. A 2 and a 6 would give me a total of 8, or B to the 8th. I don't have anything to go with the 2. I don't have anything to go with the A to the 3rd, so therefore that would be my final answer. All right. 2 more. Make it a little bit harder. Okay. Take a look at this one for a second. Okay, you can see here that we have the power of a product that needs to be applied right here. There's a power outside the parentheses. It's got to go to both the n and the y. So that'll be an n to the third and a y to the third. And I really have yet to do anything with these first two sets of parentheses. Now, as I look at these, I see coefficients, I see n's, and I see y's. So here, if I'm going to multiply, okay, another thought might be, you think about it this way. -2 and -6 would give you a total of positive 12. N to the 6th, n to the 3rd, and n to the 3rd, same base. I can put all those together for a total of n to the 12th. And I can do the exact same thing with the y's. 5, 2, and 3 is a total of y to the 10th. Okay, so again, I started up here, and I was ultimately able to condense it all the way down to that. All right, last one. Okay, again, I see a power outside of a set of parentheses. That power must be applied. It's got to be applied to all those pieces. So for a moment, this first one is going nowhere. And I am now going to give that power of 4. I'm going to give it to the -3. I'm going to give it to the a to the 3rd. And it also will be applied to the n. Okay, so for one more step here, I guess I can leave this all go. -3 to the 4th power. That's 81. Here we have power raised to power. That's multiply. It's a to the 12th. And we have n to the 4th. Okay, at this point, I have no more powers on the outside. I am now ready to use the product rule to put these final results together. So I have a -3 and an 81. That's -243. I have an a to the 3rd and an a to the 12th. It's an a to the 15th. And I have an n4 and an n4. That would be an n to the 8th. Okay, so I can take those and put those together as follows. It is not realistic to think that you would make it from the beginning, the white problem, to your answer without doing a little bit of simplification work along the way. So please don't just think you're going to jump from beginning to end. You do have some questions in your Google form tonight that look very similar to these. So please make sure that you have these down in your notes with the work that would go with them prior to trying to do your homework. Now, the last thing in your homework that I'm going to model for you today is something that looks like this. All right. The question here simply says, find the area of the triangle below given the following information. Well, how do you find the area of a triangle? I guess the first thing we better do is we better know the area formula for a triangle. So, area formula for a triangle, if you do not know, is 1/2 of the base times the height. Okay, 1/2 of the base times the height. Well, it tells me that the base of the triangle is 8x to the 4th. So if we take this statement here, we will have 1/2 of 8x to the 4th. And it tells me that the height of this triangle is 5x squared. All right, and I simply will go ahead and multiply those together. Because I have no powers on the outside, the only thing I really need to do is I will use the product rule to put all this together. So for a second, I have 1/2 times 8 times 5, that's 40, x to the 4th, x to the 2nd, that's x to the 6th. All right, and because at this point, the 1/2 and the 40, those are both numbers, a coefficient and a constant, I can put those two together, and this will leave me with 20x to the 6th. So you do have a question tonight on your homework that is going to ask you to find the area of the triangle. You will need that formula to find the area of a triangle, 1/2 of the base times the height. And you are also going to need the area formula for a circle. So in this case, sorry if I can get all this away from here, pi times the radius squared will give you the area formula for a circle. Okay, remember the radius is halfway through the circle. So if we move this out of the way for a second, we can slide that over there. All right, if you had a circle on your paper, so let's just go with that. That'll give us a circle. Okay, and let's call the center of it about right there. That distance right there would be known as the radius. Okay, or if you had a line going all the way through the circle, that is known as a diameter. And a diameter is really simply made up of two radiuses. So the diameter of a circle is exactly the same as two radiuses of the circle. So if I knew that the diameter was 10, let's say, then that would mean that the radius has to be 5. Or vice versa. If I knew that the radius was 5, that would also tell me that the diameter was 10. Okay, so I'm going to need the area formula for a circle, pi times the radius squared. Going to need the area formula for a triangle, 1/2 of the base times the height. And there is one question about a rectangle. Hopefully we know that the area formula for a rectangle is length times width. All right, so if we've made it to this point and your notes look good, then by all means, please go ahead and start your Google form. If not, then maybe you need to go back and watch anything. You can always find me during office hours if you need me from 1:15 until 2:30 using my last name, Coughlin, to join. Have a great day, guys. I'll see you tomorrow.